take a picture? And then just like grab the camera.
Okay. Reactions. Let's make it fatter so you can see. Chemical stories. I'm going to call them chemical stories. Okay. What I call a chemical story is a chemical sentence or a chemical reaction. Okay. And again, we kind of touched on this a little bit, but let's say we have a chemical story or a chemical reaction that looks like this. On the left side, we call those the reactants. On the right side, we call them the products. And this arrow that's right here, that's not a highlighter. This arrow that's right here is where all the chemical magic happens. Okay. So when we have a reaction that's taking place, we start with A and B, and we produce C and D. A and B do not exist at the same time as C and D. Okay? Let's look at one that's an actual reaction, because I just used letters, and sometimes it might be a little bit more confusing. Let's say we start with H2 and O2. And we are making H2O. So, hydrogen is a gas. This little G after the hydrogen means gas. This O is also a gas at STP, standard temperature and pressure. And water will make it a liquid at regular old temperature, what we are at right now. Okay. So if I were to draw this out, it would look kind of like this. It would be H and H. It would be O and O. And then it would be H2O, and it would look like this. Okay? Everybody stop drawing for a second and just look. Just look. Eva, you with me? Yeah. Okay. Let's pretend that this is not here right now. Okay? If I start with two H's, 2 atoms of H, or 2 moles of H, because really we're talking about moles, okay? In order for a reaction to take place, these 2 atoms need to break apart. Energy needs to be absorbed. Barf. Broken, absorbed. So we would break these apart, and we would move them like that, okay? When that happens, now they're here. They're at the arrow. This is where the magic happens. Oxygen also would have to break apart. And once they get here, now they can mix themselves up, and they can do what they need to do, and they can be like, woo, I'm going to go play with my new friends, okay? And then they're going to say, okay, let's make a water molecule. What about this guy? Well, not really. What happens is that guy needs to be accounted for in this reaction, because there is something called the law of conservation. Write this down. This is important. It says matter, and this is matter. Matter is the atoms. Cannot be created or destroyed. So right now, we have a story that's being told where one of these oxygens atoms, one of these moles of oxygen atoms, is not being accounted for. Okay. Can I put, don't write anything. Can I put a 2 here and just stick this oxygen on here? Why not? Because if I did that, would I have water anymore? No. And I'm trying to make water. So that's not going to work. I cannot put this 2 on here. I know I'm making this. So this guy needs to be accounted for. So we have more numbers that we are going to use. These numbers are called the coefficients. They're numbers that go in front. And those coefficient numbers can be any number you want them to be. What you cannot do is you cannot change the subscripts. Now, we spent from September-ish to now talking about where these subscripts are coming from. The subscript for this H is a 2 because, anybody remember? There's 2 of them, but why are there 2 of them? What kind of element is that? Starts with a D. It's diatomic. That's why it gets the 2. Okay, and there are 7 diatomics. We went over those. You need to know them. Okay, this oxygen gets a 2 because it is also a diatomic. Why is there a 2 here on this H? That help? Why is there a 2 here on this H? Because you crossed them down, right? So when we write our formulas, we get the subscripts from the from the oxidation numbers or the charges of whoever its partner was. And we spent a lot of time doing that. So formulas are made by doing that crisscross thing that we talked about, or if they're covalent, then we talk about the prefixes. Atoms, they're either monoatomic or diatomic. But these subscripts are what they are. You cannot change them. You can, however, change the coefficients, which tells you how many groups of those you have. Okay? We need to use numbers in those coefficient spots. Coefficient, coefficient, coefficient. That is going to allow all of what I have when I start to be accounted for when I'm done. Right now, I've got a blue left over. So what I'm going to do is I'm going to move these suckers back to where they were. Okay. And I'm going to say to myself, self, right now, I have 2 atoms of hydrogen over here, and I've got 2 atoms of hydrogen over here, so that's good, but I've got 2 oxygens and I've only got 1. What number can I put in front of this water so that when that is distributed, I'm going to end up with 2 oxygens?
2.
It's going to put a 2 there. Don't write. I'm going to show you a trick to doing this in a second. Okay? If I did that, if I put a 2 there, then really what I have is I have 2 H2Os. Oh, that blue circle is big. Okay, so I have 2 blues. There's 2 blues over here. And I've got 2 of these, but I've got 2 more. So what do I have to put in front of this? A 2. And that means that I must have started with 2 groups of H2. How many groups of oxygen do I have here? No. I have 1 group of oxygen. 1 group of O2. Okay? Now let's pretend that these guys don't exist. Okay? Just give me 1 second to finish this and I'll give you a break. All right? If I do that, and at the arrow, these guys all absorbed energy and they start to break apart. Okay? And this guy comes over here and breaks apart. can I now make 2 H2Os? That's law of conservation. The stuff that I started with has to be the stuff that I end with. And the way we make that work is with these coefficient numbers that are in front, here, here, and here. All right, take a break. I'll stop the video, and then I'll continue when we get back. Okay, back in business. Back in business. Okay, now let me teach you how to do this. So now you understand the concept where the stuff that you have on the reactant side has to be equal to the stuff that you have on the product side, atom for atom, not coefficient for coefficient. Because, Evie, got it? All right. Atom for atom, whatever you have on the reactant side has to be what you have on the product side. Okay? That's law of conservation. Let's try another one. N2. Why am I putting the 2 on the N? Diatomic. Plus H2. Why is the H get a 2? Diatomic. Will produce ammonia, NH3. Okay, ammonia, we know the formula for ammonia is NH3. Okay? Does this reaction obey the law of conservation? Is the amount of stuff I have on this side equal to the amount of stuff I have on this side, atom for atom? No. So we need to put numbers in front. I cannot change subscripts. I can only put numbers in these 3 spots, these coefficient spots. Okay? This is how I'm going to teach you to do it. This is one of the ways I'm going to teach you how to do it. There's a couple. But let's start with the easy way. This is called balancing by inspection. Inspection means I just look at it and I balance it. I'm going to make a line, and I'm going to do it in red, that splits my reactants from my products. So here are my reactant side, here's my product side. On the reactant side, I have nitrogens and I have hydrogens. I make a list of all the atoms I have. I have 2 nitrogens and I have 2 hydrogens total on this side. Now I'm going to make the same exact list, N and H. I've got 1 nitrogen and 3 hydrogens. They don't match, so we know it's not obeying the law of conservation, which you already told me. Okay? Always leave your H's and O's for last. So H's are going to be last in this case. We're going to work on the N's and get them to balance. Look at these 2 numbers, 2 and 1. Which number is lower? 1. 1 is on the product side. Because it's on the product side, the N on the product side is what we are working on. Okay? What number can I put here? Forget about those numbers now. What number can I put here that when distributed to this NH3 is going to give me this number? What number can I put here? Okay, now, you see that changed? Once that's done, these numbers right here don't work anymore because I don't have 1 N anymore and 3 H's. I have to recount everything that's on that side. How many N's do I have now? 2. And how many H's do I have? 6. Okay. The N's are now balanced. That's called, N's are obeying the law of conservation, but the H's are not. What side am I working on? The reactant side, because the 2 is lower than the 6. Find the H's on the reactant side. They're right here. These numbers now are gone. I'm just using those numbers to tell me where I'm working. What number can I put there that's going to give me what I need? 3. Okay. Recount. Did the N's change? Did the amount of N's change? No. Did the amount of H's change? Yes. Now am I obeying the law of conservation? Okay. Because all of these match now, I'm obeying the law of conservation. What number is here? Right here on this line? 1. Okay. If there's nothing written there, It's a 1. And the reason I bring that up is because sometimes the question is, what is the sum, that means add all of them up, of the coefficients? 1 plus 3 plus 2 is 6. That's the sum of the coefficients. Okay, let's try one more. Magnesium plus aluminum sulfide yields magnesium sulfide and aluminum. Okay. Let's make a line. Let's count how many we have. So we have got on this side, we've got magnesium, we've got aluminum, and we have sulfur. I'm breaking everything into its pieces. This side, I have magnesium, aluminum, and sulfur. Keep them in the same order so that it's easy to compare. Okay? How many magnesiums do I have on the reactant side? 1. How many aluminums? 2. How many sulfurs? 3. All right, 1, 1, and 1. Do you know why these guys don't get a 2 on the subscript? They're not diatomics. Okay. These are the only 4 spots we can put numbers. Where should we start? Do we start with the magnesiums? They're already good, right? 1 and 1. So let's move down the list. Aluminums. Okay. What side am I going to put a number in front of? The product side. The right side. Okay, the product side. So my next number is going to go here. Soon as I determine that, and this is important because you're going to mess it up, those numbers don't exist anymore. The only thing those numbers are being used for is to tell what side I'm putting the number on. So I'm putting a number here. What number am I going to put here that is going to give me 2 aluminums? 2. Okay? So now I recount. 1 magnesium, that didn't change. 2 aluminums, 1 sulfur. All right, now my sulfurs don't match. You with me? So what side am I working on? The reactant side or the product side? Product side. In front of the MGS. Once I determine that, please erase these numbers. Get rid of them. Don't look at them ever again. What number am I going to put here that will give me 3 S's? 3. Now I recount. 3 magnesiums, 2 aluminums, 3 sulfurs. Okay? Now my magnesiums don't match. So what side am I working on now? The reactant side. Good. Where am I putting my next number? Right in front of this magnesium. Once I determine that, I cross these off. What number am I putting there, Caleb? 3. Then we recount. 3, 2, 3. Now it's balanced. Okay? Balancing reactions. Making the stuff you have when you start equal the stuff you have when you're done. What number is here? 1. What's the sum of the coefficients? 9. What's the coefficient in front of the magnesium sulfide? 3. Magnesium sulfide's right here. Coefficient in front of it is 3. Okay? Oh, let's try one that's a little bit harder. Getting a little more complicated now. We're going to start to step things up. Nah, don't be scared. Okay? It's not hard. It's the same steps. Okay? We're going to put a line here, we're going to add or make a list of all of our elements, C, H, and O. How many carbons on the reactant side? 1. How many hydrogens? 4. How many oxygens? 2. On this side, 1, 2, and 3. Okie dokie, Smokey. Here we go. Leave your H's and O's till the end, which is easy because the carbons match in this case. O should always go dead last. And let's hope it works itself out, because I've got a 2 and I've got a 3 here. And they're odd and an even number, so that's a problem. All right, let's work on the H's. Where do I put my next number? In front of what? In front of the product, which has the H in it, which is going to be the water. Okay, so my next number is going to go right here. What number am I going to put there that is going to give me 4 H's? 2. Okay, now count. 1 C, 4 H's. How many O's? Nope. Nope. This is why recounting is so important. How many O's do I have here? And I have 2 more here. That is why I tell you to make sure because a lot of people, what they'll do is they'll like, oh, I put a 2 here. Now I have 2 O's. I'll just add them to this 3 and think there's 5. No. You have to make sure that you cross these numbers off and recount. So how many O's do I have? 4. Okay. Now, I've got my O's that don't match. I always leave my O's for dead last. Where am I going to put my next number? In front of the O on the reactant side, because the 2 is lower than the 4. You work on the side that's lower. Cross these numbers out. You don't need them anymore. You're going to put a 2 in front of that O2. Recount. Don't look at these numbers. Recount. 1 carbon, 4 H's, 4 O's. Now is it obeying the law of conservation? Yes, it is. Okay, leveling up. Good? Okay. C3H8 plus O2 yields CO2 and H2O. Okay, let's make our line. We have C's and H's and O's again. Same elements we had last time. Count. 3, 8, 2. 1, 2, 3. I love these equations because the CHO is always 1, 2, 3 on the right side. Okay. All right. What one are we doing dead last? O. Okay. Let's start with the C's. How many C's do I have, or what number am I putting in front of here so that I am going to get 3 C's? 3. Okay, recount. How many carbons do I have now? 3. How many oxygens do I have?
6.
Listen to Allison. Was it Allison that just said that?
Yeah.
Okay. I have 6 here, and I've got 1 more sucker over here. So I've got 7 oxygens, and how many hydrogens? 2. Okay. Well, that didn't help me because I still got an odd and an even, so that's a problem. Hopefully it works itself out. If not, that's what I'm going to show you to do next. All right, so we've got H's we have to do next. Oxygens go dead last. Do your oxygens last. 8 and 2. We're going to work on this side, the product side, in front of that H. What do you want me to put there? A 4. Okay. Recount. 3 carbons. How many oxygens do I have? Well, we got 8 hydrogens. How many oxygens do we have? 6 here, and 4 here. It's 10. Good news, right? You see why I left oxygen for last? Okay, it's not always going to work out that way, but because I left oxygen last, I didn't have to worry about an odd and an even. Now what number goes in front of this O2? 5. 3, 8, 10. Okay. Last example of the day. C4H10 plus oxygen yields CO2 and water. Last one of the day. Then I'll let you work on your CASA learning. We got some numbers here. We're going to draw our line just to keep things consistent. We're going to make our list, C, H, and O. Oh, those are big. C, H, and O. Oh, Mr. Valerio, how are you?
Good. The dream.
Living the dream. We got 4, we got 10, and we've got 2. I'm going to start moving a little quicker. You all right with this?
Yeah.
Okay. 1, 2, 3. I love that. Whenever you have carbon dioxide and water, it's always 1, 2, 3 for carbon, hydrogen, and oxygen. Okay. That being said, you're not there yet, so count them. 1 carbon, 2 hydrogens, 3 oxygens. Okay. We're going to leave oxygen for dead last. Let's deal with the carbons. What number should I put here? 4. Okay. Recount. 4 carbons. How many hydrogens? 2. How many oxygens?
9.
Thank you. 9. Do you understand why?
Yeah.
Okay, 8 here, 1 here. That's 9. All right, let's deal with the hydrogens. We're going to work on the product side. We're going to go in front of this hot water. What number am I going to put there? That's going to give me 10 hydrogens. 5. Okay, recount. 4 carbons. 10 hydrogens. Oh, that's good news. 8 plus 5 is 13. Shoot. You got a problem. You see the problem?
Yes.
Okay.
I'm scared.
No, it's not. It's an easy fix.
It is.
Okay? It's a very easy fix. You ready? What? We know that we have to put a number here. Does everybody agree we have to put a number there?
Yeah.
Okay. All right. I can get rid of these now.
Oh.
What number? Psst, it's not a whole number. What number could I put there that's going to give me 13? 6.5. Okay. Don't write it. Just look for a second. 6.5. Okay. Can I have a fraction, a half, as a coefficient? No. So what I need to do is I need to double every coefficient to eliminate that half. Okay? Because what this is actually doing is it's setting up a ratio. This number is a 1. This is a 1 to 6.5 to 4 to 5. This has to be a whole number. You cannot leave it as a fraction. No, no, no. Okay? So if you have 1 C4H10 and 6.5 oxygens, and you're going to get 4 carbon dioxides and 5 H2Os, and I need to get rid of that half, the only way to do it is to double all your coefficients. If I double the 1, I'm going to end up with 2. If I double the 6.5, I end up with 13. If I double the 4, I get 8. And if I double the 5, I get 10. So that gets rid of these 4 numbers. Now we recount and make sure that everything matches. if I've got 2 in front of this, how many carbons do I have? 8. How many H's do I have? 20. How many oxygens do I have? 26. Okay, now let's make sure this side matches. How many carbons do I have here? 8. How many oxygens? Oh, I'm sorry, do the hydrogens first. 10 times 2 is 20. And then 8 times 2 is 16, plus 10 more is 26. Does it match? Yeah. It is crazy, but fun. Okay? Fun? It has to be in a smallest whole number ratio for these numbers. These numbers have to be in the smallest whole number ratio. And so to get it to be whole numbers, if you end up with a half, double everything at the end. All right. Let me stop the tape. We're going to practice.